looking forward to a nice day. For sure, it's going to warm up too and be dry. All right, cheers, Bob. Good to catch up, and a nice, steady, strong signal. No QSB at all. VK3B and C, VK5TN. Cheers.
VHF propagation beyond that of line of sight occurs by using the troposphere, the ionosphere, or an obstacle, such as the moon or a building.
VK3FLJD, portable, VK7JON.
In this video, we'll look at how the troposphere affects propagation. The troposphere is the lowest part of the atmosphere, and what takes place within its boundaries largely determines our weather. Its upper boundary is the temperature inversion layer known as the tropopause, which lies between 8 kilometres and 16 kilometres high, depending on the latitude and the prevailing conditions. The key to tropospheric propagation is refraction. Refraction is the change in direction of a wave passing from one medium to another. Keep in mind that radio waves and light behave in a very similar way. The refractive index is a measure of how fast light travels through a specific medium and determines how much the path of light is bent or refracted when entering a material of a different density. The most common VHF and UHF propagation occurs due to changes of the refractive index within the troposphere.
This is VK7DC.
Amateur radio operators broadly refer to this form of propagation as tropo. There are three types of tropospheric propagation, which take signals a significant distance beyond the horizon. Enhanced tropospheric refraction occurs when there is a significant increase above the normal value of refractive index in the atmosphere. Tropospheric ducting occurs when radio waves are trapped within channels bounded by sharp changes in refractive index. And tropospheric scattering, which arises from small-scale variations in the refractive index. These modes occur almost exclusively in the lowest few kilometres of the troposphere, where the air density and water vapour content are greatest. It's also worth noting that the refractive index decreases with height. Enhanced tropospheric refraction occurs when the lower troposphere divides into two stable layers, typically a warm dry layer over a cool moist layer. The boundary between these two layers is called an inversion. Normally, in the lower troposphere, temperature decreases with height, and humidity increases with height, which is why they are called inversions. Signals bend as they cross the inversion. When they start bending downwards, the signals can travel further, reaching places that are normally beyond the radio horizon and out of range. The base of this inversion is considered to be the ground. The top of the inversion is the air mass boundary.
What happened is easy further afield than out of Melbourne, but one patient from New Zealand come through as well.
Tropospheric ducting occurs when radio waves are trapped between two boundaries. Ducts fall into two categories: surface ducts and elevated ducts. Ducting occurs when the refractive bending increases so much that the signal hits the ground at a distance far away from the transmitter and is then reflected back to the inversion to then be refracted back down again. In essence, the signals become trapped in a layer or a surface duct. Surface ducts occur when a steep negative gradient in refractive index forms immediately above the ground or sea, trapping the radio waves by refraction from above and reflection from below. In a normal atmosphere, the air temperature and dew point, and hence the refractive index, all decrease with height above the ground. The top of the surface duct is where the inversion occurs. A duct may also be compared to a microwave waveguide, in that a duct will not propagate signals whose wavelength is too long in relation to its vertical depth.
3HJV, he's beaming the other way, and so am I, and he was still good. Alright, I'll go back and see if I can collect a few new ones. Got about 12 so far over.
Elevated ducts form when a double discontinuity in refractive index occurs. In this case, the waves are bent upwards from the lower boundary of the duct and downwards from the upper boundary. The waves can be guided over irregular terrain until the duct is broken by mountains or other changes that the duct cannot follow. Elevated ducts form at a height typically between 450 and 2,000 metres and are the origin of the longest overland tropo openings. Even longer distances can be worked via elevated ducts over the sea. Although signals are being carried far from the transmitter, receivers at low elevation will not be able to receive them. Only tall masts or locations on hills that poke into the duct will be able to receive the signals.
Alright, better carry on here. I'll go and check my tractor. She's watering the lawns again. VK3FS, VK5TN.
Tropospheric scatter is an almost ever-present condition that brings in distant fluttery signals beyond the normal line of sight.
Another hour it'll be starting to get dark, so...
Scatter arises from small variations in the refractive index of the troposphere. Changes in refractive index occur whenever there is turbulence, for example in convection cells and in any strong wind. The atmosphere is never completely uniform, and differences in temperature, pressure, and water vapour content are always present. If it were otherwise, we wouldn't have any weather. These irregularities can extend beyond the troposphere into the stratosphere. In the lower troposphere, differences in water vapour content dominate the changes in the refractive index. At greater heights, the humidity is much lower, so temperature variations become the dominant factor, and the changes in the refractive index are smaller. However, the lower density of the stratosphere leads to physically larger irregularities. Inversions are formed by two basic mechanisms. Radiation inversions occur under still clear conditions, when the land cools rapidly, cooling the air closest to the surface, but leaving the higher levels relatively unaffected. These conditions occur most often in the anticyclone weather systems, being an area of high pressure in which the barometers are typically reading fair or very dry. The other mechanism for forming an inversion is connected even more directly with the anticyclone and is known as a subsidence inversion. The air at the centre of a high pressure system descends. This subsiding air is compressed as it moves downwards into levels where the pressure is higher. Hence, it warms up. As a result, the relative humidity of the air decreases, and so does its refractive index. When the subsiding air becomes as dense as the air beneath, it will cease to sink. At the boundary between these two air masses, there will be a temperature inversion, where the normal decrease in temperature with height is sharply reversed, accompanied by a sharp change in the refractive index. As a high-pressure system develops, the height of a subsidence inversion will decrease, and the inversion may even touch the ground. Elevated ducts have a double bend in the profile of refractive index against height, caused by a combination of subsidence and radiation effects. During the day, the ground heats, and the ducts either disappear or become lossy surface ducts, only to reappear in the evening when the ground cools again. Ducts tend to develop progressively through the lifetime of an anticyclone, so the biggest tropo openings tend to occur after several days of enhanced propagation.
another station with you, Bob. Yeah, you're 5 and 5 here. 55, 55, 5 and 5, Bob. 55. Over.
There is so much more to tropospheric propagation. What's been presented in this video is an introduction. If you're interested in what's happening above you right now, and in any part of Australia or New Zealand, check out the aerological diagrams on the Australian Bureau of Meteorology website. The aerological diagram shows the current vertical distribution of temperature and moisture in the troposphere, and to determine the atmosphere stability. This chart shows the varying temperature and dew point at specific altitudes. For worldwide tropospheric prediction charts, bookmark dxinfo.com, known as the Hepburn charts, or Pascal F5LEN site. Both of these sites look many days ahead. Finally, in Australia, keep tabs on VKspotter.com. This site offers real-time textual interaction between on-air stations on all bands, with spotting of distant stations and beacons. As well, VKspotter has current tropo charts, which you can use to correlate the spots currently logged.
VK3 Echo Juliet, VK7 MD. I can hear you fine, over.
Tropospheric propagation plays a big part in VHF and UHF radio. Keep an eye skyward and look out for the visual telltale signs of ducting. Look for low-level, long cloud bands that stretch from horizon to horizon. Even if you're not a radio amateur, tropo affects terrestrial TV and FM radio broadcasts, just the same way as amateur radio. So be sure to have a listen around the bands, especially during the summer months, as you never know what you might hear.
Good evening to you, Damien. I've got you 5 and 1, 51 as well, and I'm in Burnie too. So good to make the contact with you for the first time there, Damien. I'll put it back to you. VK3EJ with the group, VK7JON.